The new topic we're starting is the second part of polynomials. Polynomials 2, it's quite short, and initially the first part is entitled Iterative Methods of Finding the Roots. The word iterative means to repeat, and in this method there's a repetition. We perform a process and it gets us closer to the root, and then we use the new answer, and then we keep going. It comes from the word something like reiterate. If I reiterate stuff to you, it means I repeat it. So we're going to do two methods, halving the interval and Newton's method, but I just want to explore finding the roots first. If we can find them, then we go and do it. This method's for when we actually can't solve, when the algebra is too hard. So in this case, to find the roots, well, what do? There's not particularly for this question, but to find the roots, I could use the quadratic formula if it's quadratic. I could use long division for polynomials. This one's quite easy though. If I make this equal to 0 to find the roots, which is when y equals 0, I'm going to take a common factor and factorise that expression. So the common factor, I could also divide by 2, but I might divide by 2 first. So if I divide by 2, it's 2x cubed minus 7x squared plus 3x equals 0. And then I take a common factor. And in this case, the common factor is going to be x outside of 2x squared minus 7x plus 3. And then I factorise, probably by the cross method in there. So it's x outside of 2x and x, 3 and 1, minus and minus. So I've got three things multiplied to give 0, essentially that's in a bracket 2. So one of them must be 0. So either x equals 0, 2x minus 1 equals 0, 2x equals 1, or x equals a half, and x equals 3. So in this case I can find the roots, and I can have a go at sketching it. So the roots are 0, a half, and I'll make that 3 up there. So you remember from the preliminary course, the curve could either go down like that, there's no double roots, or that way. And the best way of doing it is finding the y-intercept. However, in this case the y-intercept is 0. So just test a point. If we take the point 1, which is not one of the roots, so 1 is somewhere here, and if I sub in 1, I'll just put an f there, which I didn't have before, f of 1 is 2 by 1 cubed minus 7 by 1 squared plus 3 by 1. So if I get a positive, I'll know it's the top graph or the dotted graph, and if it's a negative, it's the other one. So it's 2 minus 7 plus 3, so it's minus 2. So at 1, it's a minus. So that must be the graph in this case. Okay. But sketching it isn't our aim at the moment. It's just to find the roots. And in this case, algebraically, we could do it. So no drama. But what if we can't find the roots? Okay, so what about if we have a function like this? Y equals x to the half plus x minus 1, and we want to find the roots. We can't do that by any of the methods that we know, and you're not asked to, but we're asked to show that it does have a root between these two numbers. So you're always given the two numbers between which you've got to show that there's a root. Now what does it mean that there's a root? It means it crosses the x-axis, doesn't it? So between 0 and 1, somehow this curve crosses the x-axis. Might look like that. Might be going the other way like that. At some stage it crosses the x-axis, meaning that before it crosses it, let's say it's this one here, before it crosses it y is positive, and after it crosses it y is negative, or vice versa. And so this is what the halving the interval method, which is the first method we're doing, rests upon. What we want to show and how we show it is that before the root there's one sign, and after the root there's another sign. One's positive, one's negative. Okay? And the way we do it is to sub in the two numbers we're given and show that they have opposite signs basically. So somewhere in between those two numbers, the curve has to cross the x-axis. There's no other way where for it to go. Okay, so if I call it f of x, we know that f of x equals x to the half plus x minus 1. And I'm going to sub in these two numbers. f0 is 0 to the half plus 0 minus 1. Oops. Well, the square root of 0 is 0, plus 0 is 0, so it's minus 1. So that's less than 0. And if I sub in f of 1, that's 1 to the half plus 1 minus 1. Square root of 1 is 1, so it's 1 plus 1 is 2. 2 minus 1 is positive 1. So we've got that as a negative and that as a positive. Oops. So we know that somewhere between 0 and 1, at 0 it's negative 1, and at 1 it's a positive 1. So somewhere in between there, we don't know what shape it is, okay? Somewhere in between there, there exists a root, okay? So this question is a little less specific. We don't actually have to do anything else. We've shown there is a root there. Now we're going to move on to halving the interval. So putting that into some sort of theory, and in the cloud you can copy it down. So if the function is continuous for some domain of x, in this case between a and b, so if the function is continuous here, then if f of a, which is the y value, so when I sub in a to the function and when I sub in b to the function, if they have opposite signs, so for instance, if I sub in a and I get a positive and I sub in b and I get a negative, it doesn't matter what the number is, if they have opposite signs, then a root must exist, at least one, between a and b. Otherwise, how is from a to b, the only way I can get from a to b is to pass through the axis. And there's the root there, at least one. It's not meant to be a straight line. Okay, so that's the theory. So copy that down, and then the next lesson will be halving the interval.